Hi, I'm Andrew Lowell, and welcome to the Houdini Fundamentals Collection, Volume 1. So the point of this series of exercises is really to, right away, while we're start learning Houdini, is to really learn how to think in these workflows. It's not enough just to follow some tutorials about the user interface and to kind of do very high-level techniques. That's not the point of these tutorials. The point of these tutorials is tried and true data flow methods that will help you survive any setup or any shot. And what better way to start than using direct data flow in geometry? In this scene, we're really going to take a look at what makes Houdini tick, and that is the use of something called geometry attributes. All right, so the first thing I'm going to do is I'm going to open up a new pane, split the view, and I'm going to make a new inspector geometry spreadsheet. Okay, so even though we as humans see a collection of shapes and objects and colors, the computer sees a big spreadsheet, kind of like an Excel spreadsheet. And here is where it keeps track of all of its data and kind of what's what, tagging things with IDs and vectors and values. And it's not that we're going to go through it and say, oh, that's interesting, it's 55.08. What we're actually going to do is use our understanding of how this data is working to create effects that will eventually be very advanced. And in this scene, it's not an advanced effect, but the same techniques could be used on a very advanced effect. It's kind of like an attribute playground, an attribute obstacle course. So let's take a look at how to make a scene like this. All right, so the first thing I'm going to do is I'm going to make a few shapes. Houdini is great at multi-purpose tools. So what might be a circle, a polygon circle, if we have enough sides, it's easy enough to make a triangle out of that. Using another circle, let's make a square. Another circle. Let's make a 5-sided object. Do I have anything else in here? Yeah, octagon, 8-sided object. And this could, of course, be anything you want. Any combination of nodes you want. Now, it's easy enough to like, okay, I'm going to count the sides. I'm going to make a data value based on the sides. But what if you're in a situation where these are arbitrary and you wanted to be able to count these sides directly with Houdini processing? How do we go about that? Say they're all merged together into one geometry data stream. And right now, all they have is a polygon connected by a bunch of points. They only have position. Middle clicking, I get 20 points for primitives, which is a shape, a surface, and position, that's it. Okay, so what we're going to start off doing is we're going to count the sides of each of these polygons. So I'm going to make an attribute create. And right away, I see attribute 1. It's a float because I see this decimal point. I'm going to call it sides. So that's the label of this piece of data that's now attached to every node. I have a visualizer for it in the scene. See? So there's a value of 0 living on each point. All right, and now I'm going to make that an integer, and now it's no longer has a decimal point, and I'm going to give that a value of 1, because I know that if something has 3 points, it has 3 sides. If it has 4 points, it has 4 sides. Okay, and now we're going to use a very fast, very low-level operation called the attribute promote. And what I'm going to do with this is I'm going to use it to blaze through this geometry and points. And in the process of converting each of these values living on each point to a polygon attribute, sides, point to primitive, boom, okay, now we see a value of 1 that's not living on the points anymore, it's living on the primitive. And it's pretty boring, it's just a sides 1. How does that help? Well, the reason it helps is because we can use a different promotion method. So I'm going to do a sum instead. And now you see what happened. It's like 3 points were connected to that polygon. So that means that as it's summed going to that polygon, we now have a value of 3 or 4 or 5 or 8 corresponding to the number of sides. That's a very quick right away difference between Houdini and other applications is this low level use of data. And if you want to build really powerful setups, then it's not by learning the most advanced new features, even though there's many awesome advanced new features. It's really by understanding this fundamental data flow. Now, I want to apply these shapes to a bunch of points. Okay, so I'm going to start off by a tube. I already made a tube over here, so I'm just going to copy this tube, put it over here, just so we're all kind of starting with the same sizes. And I'm going to do a VDB from polygons. And in this way, I'm going to give this tube a volume. Uncheck distance and check a fog. Okay, so I'm giving this thing a volume with which I'm going to scatter some points. Not necessarily working with attributes here, but it is still a very low-level data flow. We just want to turn off all these relaxation features, and I'm just going to adjust the density to get slightly less of these points to work with. Okay, so that looks pretty good. I'm going to have all these eventually be rigid body objects. Okay, now it's easy enough to make a random assortment of numbers between 3 and 8, but that doesn't teach us much about data flow in Houdini. I want control over these values. I want each of these points to either be 3 or 4 or 5 or 8. Okay, now we have something that a new user not really comfortable with attributes wouldn't really know how to do. So how do we take control of this? And I say, I want percentages. I want to be able to control my percentage of polygon 4 or polygon 5. I want to be able to control how many of those values. And now I'll just want them to live as the sides attribute on these things. Okay, we're stuck. How do we work through this? Okay, so we're going to work through this with some really low-level approaches. All right, so I want to do a percentage based on height of these shapes. And they're all the same height right now. But getting an edit SOP, I'm just going to kind of work a little bit non-procedurally here, because the key to working non-procedurally in Houdini isn't to be a really good modeler. It's to be in a situation where you don't have to do much. So we're not going to do much with this non-procedure. All I'm going to do with this manual change is just move them up and down. And by this method, I'm going to be able to control the percentage of shapes here. So I want this much of the square, this much of the pentagon, and not very many of these two. Okay, so this is what I want for percentages of how these shapes will be distributed. Okay, if I want more of something, we just raise it up and make more space in between. Okay, that's a pretty easy and fast way to get percentages. All right, so now let's turn this into a grid. One of the fascinating things about working in Houdini is that we can use geometry for modeling and making things pretty. We can also use geometry for pure logic, which is what we're about to do now. So here I'm going to use a primitive SOP. It's been in Houdini for a long time. It's not a new feature. And here I'm just going to scale these shapes down to 0. This allows us to treat each polygon individually. And now we can see we've just compacted that into a very small space. Now we have 3, 8, 5, 4 up here. And now I just want to get these down to each having 1 point, because here we have 20 points and they're all different assortment. It'd be nice just to have that as 1 point. So I'm going to do a fuse. A simple fuse operation in a normal package you'd only use for modeling. Here we're using it for proceduralism. Here I'm going to uncheck remove unused points. Now we have just 1 point representing each shape now, but notice they don't actually have the sides attribute anymore. They do, there's no values. Why is that? Well, it's because we got rid of the polygons. So what we'd have to do way back up here where the size attribute is present, if we want to preserve that into this next operation, what it'd have to do is attribute promote it back to a point attribute. So now we're going to go from primitive to point sides. Now average would be fine here, but because we're only going from one source, there's no reason to do anything other than first match. So the only polygon that connects these points will go to its corresponding point numbers. Okay, now we do our edit and we shrink them, and now we fuse them together. So now we have a little vertical spreadsheet of what we want our percentages to be. Okay, and then finally, I want to fit this to a 0 to 1 range, because I'm going to use this for a diagram or a diagnostic that Houdini is going to crunch on. Okay, so I want to shrink this to the 0 to 1 vertical axis. So for that, I'm just going to use the straight up transform SOP. Very low level node, very useful. And we're just going to scale this in vertically to 1 over $y max. And now we fit this to where the top one is a value of 1. See, there's our top point, and it's a value of 1. There we go. All right. So now we kind of have a little bit of percentage here. We have this much of 3, this much of 8 sides, this much of 5 sides, etc. So now let's get these points into the same format. So for that, I'm going to use VOPS, which is like a vector powerhouse of data. It allows us to work in an incredibly fast, incredibly efficient way with vectors. And all we want to do here is change the position vector. So I'm going to generate a random number based on the point number and use that for the y-axis. Here's the incoming point number positions. Here's the output position. So first we're generating a random number on each point. We can see that if we want to test that on the color. See, here's random set of colors. And then let's just make a vector out of this. So I'm going to do a float to vector. Put that in the y and use that to override our position. And now we have the same exact data format. We have a bunch of points and it's going from 0 to 1. Okay. So now it should be a fairly straightforward matter to transfer this stuff, this data information, into something with the same kind of characteristics. So for that, we're going to use a really useful tool, the ray SOP. So basically, I'm going to make a little object on each one, and as it rays to this, it's going to get whatever that attribute is, that sides value is. So I'm going to copy a grid, which could just be a square, a box. It's going to make it a little bit smaller. Let's say 0.2, and we don't need all these rows and columns. So now it's just a square, and it's got a nice little quad polygon surface. And I'm going to do a copy to points. Let's copy each grid onto each point. And now notice that data flow is just so important, because here we actually have that sides attribute, and now it's living on each copy we made. It's living on each point of the copy. Notice that that data flowed onto the copy to points. And here's where it's reflected. Here's the rules for copying attributes, which there's some presets in there. And now we have surfaces that we can ray onto. So I'm going to use a ray. I'm going to ray upwards. So I'm going to ray all of these points upwards onto these grids. That's going to be our operation right here. So I'm going to say method project rays by a vector, delete these channels, and project up. And then we're going to, once again, use data flow, import attributes from hits. And now look what we've got. We've got an 8. All the points that hit this are a 5. And I just want to move this shape up a little bit. So I'm going to go back and get my edit. And let's give this triangle a few little representatives here. There we go. Okay, so we've got a few 3s, a few 3-sided shapes that are down here. Okay. There we go. And if we check our end result, we see we've got sides from 3 to 8. We don't have any sides of 6. And we've got a way to control our percentages of each shape. And that's all by using very fast, very efficient data. This is how data works in Houdini. Okay, so now that we have these values, let's use these values for an output. We've done a visual representation, a geometric representation of the logic in our scene, and now we're going to use that. So let's apply this back to the original scattered points. These are our original scattered points. Okay, so we want to take it from about here, where they're still in our 3D space. And here I'm just going to attribute copy. All right, now this is another very powerful node similar to the attribute promote, and its job is just to copy attributes from one geometry stream to another. And the reason that this is good is because we've got exactly 876 points here and in this, and our new points, we have exactly the same topology, 876. So it should be pretty easy to copy the attribute we gathered here back onto our original positions. So here I'm going to type in, I don't want to transfer the color, I want to type in sides. And there we have it. So all of these sides just went onto our original points. Point 1 goes to point 1, point 2 goes to point 2, etc. And we should have our percentages now. Okay, that's the first step in doing something with this data. So we have a point representing the shape that we want. Now, let's copy the shapes onto that. Copy 2 points. These are going to be our points to copy onto, and we want to take our sides. So that's up here. Here's our sides, and there we go. Okay, so we're going to take it from about here, where they're at the origin, and I'm going to copy those on. Well, the problem with what I just did there is that it inherited all of the shapes, and they all still have their respected, they all have their point number here. They didn't preserve their sides attribute from before. So here's the sides attributes. This 3 is living on the 3, the 4 is living on the 4. And as we copy, the data in this is overwriting the attribute of the same name here. And I want to do a comparison. So I want to keep both. So in that way, I'm going to attribute rename. So this is not going to be sides anymore. I'm going to do an attribute rename, and I'm going to rename from sides, and we'll just call that something else, like copy sides. Okay. So now it's the copy sides attribute. And as we copy all the shapes onto each point, now we have sides 3, 4, 5, 8, and that's all going to onto a point where the copy sides was 4. Okay, and why did I do that? Well, now I want to use that to do a low-level operation. I want to say only keep this right here. Only keep where the sides are equal to the copy sides. So now we can use a delete sub, and we can delete by a logical operation. Okay, so I'm going to delete non-selected points, delete by expression, and now we can do a comparison operator and only keep where the sides of 4 equals the copy sides. So at copy sides equals at sides. There we go. Okay, so now we're able to keep this percentage. And if we wanted to change that percentage, for instance, maybe we want the most triangles. So I'm going to get my triangle, and let's raise this way up. And the higher I raise this in comparison to the other shapes, the more triangles we get. Okay. So very procedural, lightweight, responsive, a lot of power in a system like this. Okay, let's just go ahead and give these a random direction for each copy. So we're going to keep the positions, but we just want each thing to be angled a little bit. All right, so before the copy, now we need to make a vector attribute. I'm going to use vops for that. Here I want to make a random vector based on the point number, and that's the normal. Okay, so get our random once again, point number into the random. And I'm going to do a vector out of there. And then we put that in the normal. We get normals, but they're all flowing in the positive direction. To finish that up, I'd use a fit and go from 0 to 1 to also the negative axis. And now we have some random directions. And if we look at how that results in the copy, we got more interesting copies here. Okay, and let's drop them all on the ground. Poly extrude. Just give these a little bit of depth. Extrude works the same way as in other programs. In Houdini, it's very powerful. And let's drop them all on the floor. So I'm going to use Houdini 18's new rigid or RBD bullet solver. And without going into too much detail, it's really just going to treat each shape as a rigid body, and we just need to add a ground plane to it. Just drop them all on the floor from there. So let's see. Ground plane. There we go. And you can see how nice and fast that is. Okay, so now we have our pile of shapes. And if we change something up here, then we get a different pile of shapes. Maybe you want more squares, more pentagons. Yeah, we do that. Okay. So now let's come up with a way to procedurally make these a certain color. All right, and let's also deal with time a little bit. So I don't want to have to like go and scrub to this point in the scene. I really just want the pile of these shapes. So for that, I'm going to use the time shift node. A time shift just cooks everything above it at a certain frame. And that's really useful with what we don't want to do here. We just want to lock off the frame. So I'm just going to lock this off around frame 200. And here it's going to cook the simulation all the way to frame 200. And once it's done, then it's no longer time dependent. So you can scrub that all day. Up here it's time dependent, but down here we have our final result. We have a settled pile of shapes. So let's finish this example off by giving each shape a color. Now it would be easy enough to give the color up here. We could assign this shape a color, this shape a color, this shape a color. The problem with that is that if we do it up here, then if we want to make a change, we have to re-simulate all the way until we get our final result. And what if we want to just change the color without re-simulating? Well, we can't really change the shape without re-simulating, so it makes sense to put the shape part before the simulation because they should be simulated with the shape in mind so they can collide off each other. But the color is pretty much irrelevant as far as the simulation. And that's where we have to think like a Houdini TD. And we have to say, okay, I just want to adjust the shape or adjust the color after the fact. So I'm going to start off by making a little lookup table for the color. Once again, working positionally. So I'm going to start with a line. In Houdini, the simplest things are the most powerful, like a line. All right, so I just put this line down a horizontal axis, down the z-axis. And I'm going to make a circle out of that. So I'm just going to copy and transform. Okay, so let's do 360 copies, or 359 copies rather. And each copy, I'm going to rotate it 1 degree, maybe 360. There we go. Okay, and each copy, I'm going to rotate that 1 degree, and so we get a full circle. And from here, I'm going to do a skin. Skin's a very old node, and it's used to just loft and create a polygonal surface across. Okay, actually maybe 361. There we go. Okay, so we got our circle. Now let's color this circle. So I'm going to use this geometry to make a full spectrum color wheel. So I'm going to do VOP. And by feeding the position into the color, we get a full spectrum of color. All right, and we just want to mix the low values so that instead of blacks, we're mixing with white. So I'm going to use the distance from 0, distance. So position, distance from the origin. And if it's a high distance from the origin, put that into the bias. I'm going to mix that with the position. And if it's a low distance, it's just going to be white. 1, 1, 1. There we go. So now we've got a nice little color wheel. Okay, and we can scatter some points on that like we scattered before. And now we have a nice little lightweight, the points here inherited the color. Have a nice little lightweight representation of color here. Maybe we want a little bit more dense spread. Okay. Okay, so now let's use a positional as opposed to a topology-based copy of attributes. So up here, we copied the attribute from one topology to another topology. Okay, and that was just using point 19 to point 19, point 20 to point 20. Here, I want to say, based on how close the shape is, color the shape. So I'm going to go back and get the original shapes, and let's make a new edit. I'm just going to get these shapes close by. Right now they're all up in the air. Okay. So I just want to make a new edit. Okay, so right now they're all just down at the origin, and here's our scattered points. Okay, and before, maybe I want to make them a little easier to move around. So I'm just gonna scale them down just a little bit before the edit. Okay, so now they're there, and my points are here. Okay, so let's move these shapes to where we think they should go. All right, so maybe I want a red pentagon. Let's see, what's this? This is a square. Let's say we want a green square. Let's say we want this guy to be pinkish or purple, and this to be blue. Okay, so right now these two topologies are completely unrelated. All right, so we've only got 20 points at various positions here. We've got 31,000 points here. So I'm going to use an attribute transfer. This guy will copy attributes based on position. And as soon as I view this, we'll see that the color has been transferred positionally. Okay, and if you want to be more specific about it, there are exact attribute controls as well as distances and blending for the attributes. 10 is more than sufficient for what we have here. Okay, so there we go. Now, it's one thing to have our color on these, but it's a completely different thing to have our color on these. How do we make that? Because here we have two opposing situations. We don't have the same positions, and we also don't have the same topology. So really, it seems like we're completely in a bind. There's no way to get these colors onto their corresponding shape. If we use the attribute copy like we did before, so I'm going to copy from that onto this, we get some colors, but notice it's different for different point numbers because the topologies just don't match. Similarly, the attribute transfer, if we were to transfer from this to this, see now we have a positional transfer that also doesn't work. So we're in a bit of a bind here. What should we do? Well, they both share the sides attribute. This one has proper sides attributes, 3, 8, 5. This one still, due to the data flow in Houdini, also has the right sides attributes. So when we attribute copy, we're going to copy based on topology, but also match by sides. And you'll see how attributes can be incredibly powerful if we wanted to move around one of our shapes. We can get a different color for that shape. Let's say we wanted the, and now you play around. Now it's time to have fun with the system that you spent so much time creating. So let's say we want to view that. I want to make our square I want to make our square blue instead. I want to make our triangle and all the other shapes very warm colors. Let's see how this plays out. There we go. So incredibly fast, incredibly powerful changes, some of them highly procedural, some of them not that procedural. And this is really harnessing the power of what Houdini's best at is proceduralism. And that can translate into incredibly complex simulations, not doing too much in simulations. So as we progress through the fundamentals, we're going to get more in tune with this data flow and use it for some fairly powerful techniques.